A digital twin is a dynamic computer-generated model of a physical asset, such as a building, a bridge, or a chemical installation. Digital twins are used to control and visualize parameters in a real-world asset. Example, a digital twin of an apartment building can be used to visualize the temperature or humidity inside the apartments. All data of a digital twin is stored in topics. Here we see some data collected for a car, such as speed and acceleration. The system keeps track of when and where a value has changed so that we can show the data in a timeline or on a map. Data can be imported from CSV or JSON files. You can map the values in the data source to topics and use JavaScript expressions to convert data. You can also read data in real time from sensors using MQTT or REST, or connect to third-party platforms such as OpenWeather, Tesla, or Tuya. Another way to enter data is by using web forms on browsers or mobile devices. For example, an inspector can use a form to inspect a room after a tenant has moved out. Forms can have text fields, date pickers, checkboxes, or signature fields. You can quickly design your own form by a simple text-based language. To store more information on an object, just add another field to the form. Once the data is collected, you can create dashboards to visualize your data. Using polynomial regression, you can analyze trends and make forecasts so that you can prepare for the future. Forecast of more complex data, such as the server load per hour, can be created with the built-in neural network functionality. The yellow line shows the average trend of server load. You can make more precise predictions by adding more features such as the hour of the day, day of the week, and number of days in service. To visualize the data in 3D, you can import a building using the IFC importer. You can turn on transparency and hide all building elements except spaces and color the spaces based on a topic, such as temperature or occupancy. If you do not have a 3D model, you can create one with the built-in solid modeler. Just drag and drop walls, slabs, or areas and add points of the floor plan. Add blocks to create openings for doors and windows. Create a building unit from saved parts and use the repeat statement to multiply the unit on the same floor. Then add stories to create multiple floors. You can quickly change the number of units on a floor or number of floors in a building. Walls and roofs can be flat, slanted, or curved. You can combine your own objects with imported models. Here we see a model of a valve. To place the valve in a chemical installation, we define topics that specify the position, orientation, scale, and color. By clicking on one of the valves, you can change its properties. Here we have created a heating system with radiators, a convector, piping, and a heat pump. We can combine this system with a building of a home. When you click on an element in the system, you get real-time information about temperature and pressure. You can set the thermostat or browse to a next page to see photos or documentation of the system. Digital twins can be used to dynamically visualize data. For example, the charge level read from an electric vehicle can be used to scale the 3D battery in the model. Data read from equipment can be used to dynamically update the 3D model of a moving vehicle. Data obtained from real-world traffic controllers can be used to update colors and lights in the digital twin. Wind turbines can automatically rotate or change their rotation speed based on real-world wind conditions. Once your digital twin is set up, you can create automations for controlling building systems using visual programming. You can create automations by dragging statements from a library into a workspace. The statements allow you to read and set parameters in the digital twin. You can also add if-then-else statements, loops, or timers to make smart automations. With the monitoring module, you can use visual programming to detect anomalies and monitor compliance. For example, a script that checks if the office temperature during business hours is above a certain value.